All right, welcome everyone. Now, this is chapter 9, thinking mathematically, I should say, Math 121. And in chapter 9, we're really going to focus in on measurement. So it's going to be an exciting chapter. This is literally things that we'll use in our everyday life. So in this first section here, we're going to look at measuring length and the metric system. The metric system may not be familiar to you. It is a system that is used worldwide. However, in some parts of the world, like the US, we use the imperial, or what we call the standard system. So we're going to spend some time kind of exploring that and making sense of it. So in today's lesson objectives, you'll see things like we'll look at how you change between different units, and then also some of the prefixes or some of the naming conventions in the metric system. And then also a really cool tool is the idea of using dimensional analysis to help change from and to the metric system. And also for a bonus feature, we may look at how you might use this dimensional analysis in general. All right, so length is our first topic here. Linear units of measure. This is things that we think about in terms of like distance, is what we mean usually by linear measurements. In the US system, we have 12 inches is 1 foot. 3 feet is 1 yard, 36 inches is 1 yard, and 5,280 feet are in 1 mile. And so these equivalencies here that you see here, these equations that you see, these are what we're going to use as that conversion factor, going back to what we talked about here in this first one between changing sizes. So every metric has a sort of conversion factor between one form and another. And these are some of the more common ones in the US or English measurement system. So if you, for example, measured something using a ruler and it was in inches and you wanted to know what that was in terms of feet, you could use this relationship here to make that connection. Okay. And so you'd have something along one of these dimensional analysis tools to kind of make that jump into going from inches to feet. Or let's say you wanted to know, if you measure something in feet, like maybe you measured something that was like 13 feet long, and you wanted to know, well, how many yards is that? Again, would be things that you'd want to know. Or if you ever wondered, like a football field's 100 yards, like how many feet is that? Or how much of a mile is a football field? Okay, so those are the kinds of questions that you could answer in this type of analysis. All right, and so let's dive into what dimensional analysis is. It's a way to convert between one measurement unit into another by using these unit conversion factors, right? These ideas like this. I think you can read the rest there if you're curious about more detail in the definition part. But really, if you just think of it as it's a way to go from one unit measurement to another and a relationship that has a connection. And don't let the word fraction scare you. Typically, you'll be using a calculator to compute these. And we're going to look at how the unit here, the value of the measurement, can really be a tool to help us to convert between systems. So instead of being something kind of scary, it actually is very helpful. Okay. All right, let's go in a little bit further here. And so here's two examples that could be kind of our first window into that. So say we have 40 inches and we want to know what that is in feet. Okay, so if you look here, we have 40 inches, and the trick to doing these is to look at this and go, oh, you know what? I'm given this measurement here in inches. I have inches and I want to know what it is in feet. So I need to know, my top measurement here needs to be in feet. And so if we look back here at the unit measurements, right, I'm given inches and I want feet. So if I have this one, it's not going to work. I want my inches that I have here, if you can think of it as like canceling out with my inches down here, and then that leaves us a unit that we're after. In this case, we wanted to have feet. So the trick with these unit fractions is to really recognize, okay, what are the units that I'm given, and what are the units that I want? And then all you need to do is just match up that the units that you want are upstairs and the units that you want to get rid of go downstairs. Okay, and as long as you keep the right number with each one, then those will reduce to one, and you're going to be left with the units that you're looking for, which I think is super helpful. When I was learning how to convert between units, I found that that was a really great tool to kind of help me make sense of things. And so let's look at that in action here. So we have 40 inches, and I want to get rid of inches. And so I'm going to write inches. So there's 40 inches over 1. and I'm going to multiply that by my unit here is 1 feet over 12 inches. Now notice the feet are what I want. The unit is the feet. That's what I'm looking for, right? That was what was given here. And I want to get rid of the inches. So the inches are going to go downstairs. And now with this, I can just multiply straight across. 40 times 1 is 40. 12 times 1 is 12. And so I've got the inches canceling off, and I have 40 and over 12 feet. And that's a completely acceptable answer. Or we can reduce this. There's a common ratio that goes into both, or a common number that we can reduce this by, or we put it in the calculator, and if we did that, we would get 3.3 with the 3 repeating forever. So this is 3 1/3 feet. So 40 inches is about the height of my son, which is 3 1/3 feet. Okay. Another one, let's say we have 13,200 feet. That could be example, the height of a really tall mountain. For some reason, we measure really high mountains in feet. And so if we wanted to know how many miles is that, again, this is what we were given, the feet, and we want to get rid of, or we want to convert it into miles. And so if we ask, all right, so if I have feet and I want to get rid of feet, okay, then this is what I was referring to earlier. I should have written out. So I want miles. Okay, so I need the feet to cancel. So how many feet are in a mile? Well, if we go back up here and look, we see that there are 5,280 feet per mile. But this is the wrong order because I have feet upstairs. So I need my feet to go downstairs. So there's 5,280 feet. So there's going to be 5,280 feet, which is what you see here over 1 mile. And then the 13,200 feet or what we're multiplying by. So that number goes there, and this number goes there, and then there's one, and that's in 1 mile. Okay. So then we multiply those across, and now this number we would typically take into a calculator and divide, and you get that it's 2.5 miles. So notice that this really big number in one unit can be very small in another. So 13,200 is a huge number, and in the miles, it's only 2.5 miles. And again, that speaks to the fact that there are so many feet in a mile. Okay. All right. So let's dive a little bit further then. So now that we've kind of looked at units in a maybe more familiar setting, let's convert over to the metric system and look at what both the naming conventions are and how are they related to each other. So the metric system is used in most industrialized. In fact, it's pretty much used everywhere else in the world except for the US and I think one Asian country, and maybe Britain still is known for the metric system, but they still use a ton of their imperial system too. So you got to kind of have, they're kind of like us. Like we buy sodas in liters, which is a metric unit, but we talk about driving 60 miles an hour. So that's an imperial unit. So anyway. All right, so let's look at the metric system here. Kilo is the symbol K, and it's 1,000 times the base unit. So these prefixes, I think if I can remember correctly, I think these prefixes are Latin and then these are Greek, but don't quote me on that. So anything that's a smaller one in the metric system is, and that's not something to be tested on or anything like that. Just kind of a little, a new fact that I'm coming across. If it's not that way, it's the other way around. I forget which exactly it is. So probably shouldn't say that, but anyway. So you have deca, which would be like 10 times the base unit. Hecto, we don't usually use hecto, but that would be 100 times. And then kilo, which would be the 1,000 times. So you may hear things like kilograms. For example, if you go to maybe like the gym, you might see the weights that are in a gym. You might say like 45 pounds or 22.5, I think, something like that, kilograms. I'm trying to think of where else you might see it. If you go to like Canada or Mexico, or in most other countries, they talk about things being measured in kilograms. So that would be a weight. Also kilometers, you would definitely see. Sometimes we talk about distances in terms of kilometers. Trying to think of common usage. I'm mostly thinking like races, like for running races. You might hear about running a 5K, right? So a 5 kilometers is like 3.2, 3.1 miles, something like that. Um, but you usually don't hear about hecto in a lot of context. I don't think I've come across it, but it's very rare. And deca, a similar situation. Yeah, I'm not thinking of anything that really comes out in that, but those are 110 times. And then the deci, this one you would definitely feel. You should recognize deci in terms of decimal, which is our numbering system, right? Our numbering system is base 10. And as you should see here, these are also base 10. So the decimal actually comes from the fact that our values are base 10 here. Okay, so they use the symbol D for decimal. Centimeter or centi is often used. Centimeter, I gave as an example before I said it, but centimeter is very common. So that's 1/100th of the meter. Um, so I think that's probably the most common one. And then same thing with milli. This one you might hear in milliliters as well as millimeters. Um, and you should also know that 1 milliliter is 1 cubic centimeter. So those are a nice relationship as well. Okay. All right. So let's look at, and also notice here that the meaning of them, as you go up the scale, you're multiplying each power by 10. And as you go down the scale, you're dividing each powers by 10. So this is really one of the things that's really popular, why the metric system is so useful is the fact that it's a base 10 system. So unlike our conventional system, like with the foot and all those, where you have these really strange relationships, like 12 inches to a foot, 5,280 feet to a mile, right? Those are very kind of almost seeming random distances or relationships, right? With respect to the metric system, it's always 10 greater, 10 less than in terms of multiplication, which is really nice. Okay. Commonly used in the linear system, meaning like a distance, you have kilometers or kms, hectometer. I think the most common usage I might see hectometers in is sometimes we refer to square hectometers in terms of like a land kind of thing, like referring to space in a not like an acre, but like an acre. Not it's not as big as an acre, but kind of like that same sort of relationship. Decameter, very rarely will you hear that actually used, but it's good to know that what it is. That's a 10 meters. Okay, of course, the meter you will hear quite often. Decimeter, again, one that's not very commonly used. Centimeters and millimeters, those do get used a lot more. Or at least in my experience, I've heard them a lot more commonly used than the decimeter. These are often confusing too if you're not seeing them. The hecto and the deca versus the deci. Okay. Um, so I don't know how many tricks for those. Just recognize that there's a difference, right? So the hectometer, the decameter, and then the deci. Okay. Um, all right. So changing within, as I mentioned earlier, there are powers of 10. So if you're converting, like if you're given something in meters and you want to know what it is in kilometers, okay, you would be, so let's say you had something in that's 5 meters, okay, and you want it to go to kilometers, okay, then just like before um, with the trick with the unit conversion, there are 1,000 meters in every kilometer. Okay, so what do we want? We want kilometers. So I have 5 meters, and I want to get rid of the meters, and I want to put in kilometers. So notice it's exactly the same process, even though we're in the metric system instead of our standard system. Okay, and so there are for every 1 kilometer, according to this, right? For every 1 kilometer, there are 1,000 meters. Okay, so I'm going to put, instead of writing 1,000, I'm going to write 10 to the third, just to not make a bunch of crazy zeros like that. So 10 to the third is 1,000. Okay, and so I'm going to have 5 times 1. Notice that the meters are going to cancel out here, and I'm left with 5 over 1,000. Maybe I'll make it try. Oh, hey, that won't. All right, so it's 5 over 1,000. So this is in kilometers. Okay, and so you can see I could reduce this, but that's a really small kilometer, right? So, and that's because I only have 5 meters, so it's a very small kilometer. However, notice if I had 5 meters and I wanted to go to, let's say not kilometers, but let's say I wanted to go to millimeters. Okay, so I wanted to know how many millimeters 5 meters is, right? That's the thing I'm looking for. Okay, so I'm going to do exactly the same thing. I'm given meters. Okay, so I'm doing exactly the same thing as I did over here. I want millimeters. So I want millimeters, okay, and I want to get rid of meters. Okay, so for every 1 millimeter, there are 0.001 meters. Okay, so for every 1 millimeter, there are 0.001 meters. And so I have 5 meters. Okay, and so here I'm going to cancel out and I get my units in millimeters. And if I divide 5 by 0.001, I'm going to end up with 5,000 millimeters. Okay, and this may seem odd at first, like why is this number so big and this number so small? But here's the way to think about it. Okay, for a metric, right, a millimeter is very, very, very close together. In fact, those are probably maybe even too big. But these are the millimeters, okay? Whereas a kilometer is really, really big, right? So if I have 5 meters, let's say this is not to scale, but this is to try to give you an idea. So let's say we have maybe like there's 5 meters. Okay, I'm gonna have a lot. I'm trying to make it. I'm gonna have a ton and ton and ton and ton and ton. In fact, I'm gonna have 5,000 of these little marks along this length to get to 5 meters. Okay, so that's why there's such a big number of the smaller unit because they're so small that I need a lot of them to make up that distance. But the kilometer is so big that it's way over here. And so it's just this 5 meters is just a very small part of the total distance. Okay. So a kilometer is all of this distance. And so even at 5 meters, we're still not even, a very big percentage of the way there. So there's going to be a very small number of meters of these 5 meters in the full kilometer. Okay. So that's what this is relating to. So if you're going from 1 unit and you're going down, right? So if you're going from a bigger unit, I'm going from 5 meters to millimeters in this situation, I'm multiplying by 10. And if I'm going from, in this case, I was going from 5 meters to kilometers, then I divide by 10. And so this result here, this 5 divided by 1,000, is also the same thing as 0.005. So you can see it's a very small number in terms of the number of kilometers. Okay, let's see, changing units within the metric system. So that's what we just had there. So if we wanted, again, go from 504.7 meters to kilometers, again, we're going from the big unit to the small unit. And so just like we did before, okay, we're going to go, we're given this and we want to go that way. So we're going to end up dividing by powers of 10. So this 504 in terms of kilometers is the same thing as moving the decimal place 1 for every power of 10. So 1, 2, 3. And so we end up here with 0.5047 kilometers. Just to relate it again, so the meters times, I want kilometers. That's a K, and that's an M. And I want to get rid of meters. Okay, so that for every 1 kilometer, remember there's 1,000 kilometers, or sorry, 1,000 meters. And so 504.7, the meters cancel, and I end up moving the decimal place over 3 times because I'm dividing by 1,000. So that's the relationship. I don't want you to think this comes out of nowhere. It has to do with the fact that we're doing exactly the same thing, right? We're given a small unit and we're trying to go to a big unit, and so we're going to end up dividing by the number of units, or the number of powers of 10. Okay, here we're going from a big unit to a small unit. So here we're going to multiply. And I think it makes sense if you think about the small unit, there's going to be a lot of them in a bigger unit. And so the number will be bigger, right? So you're going to expect to have more of them in there. Just to give you a picture here, if this is my 27, actually not even 27, let's just say 1 meter, right? Let's just say 1 meter. So I have 100. Remember, the centi means 100. I have 100 of these little marks in here, and that was so small I couldn't draw them all in this 1 meter. And I have 27 of those, right? So I have 27 of these. I have to copy and paste this 27 times. So I have 100, 200, 300, 400. So it's going to be very clear why it's going to end up being the result here of 2,700 meters, right? So I have 27 meters. I'm going to multiply this by, I want centimeters. I want to get rid of meters, and so there are 100 centimeters for every 1 meter. And so again, this is why we end up multiplying. The meters cancel, 27 times 100 gives us then, of course, the result of 2,700 centimeters. Okay. Some conventional analysis between English or imperial units and the metric system. The 1 inch is equal to 2.54 centimeters. 1 foot is 30.48 centimeters. If you've ever noticed on a ruler, let me see if I so I had it earlier and it fell down. So if you ever noticed here, this is my 1 foot ruler. And if you look, the number of centimeters at the end here is not quite lined up exactly with the foot. There's a little bit left over, right? And so that a little bit left over is the 0.48 centimeters. So 1 foot is 30.48 centimeters. 1 yard is 0.9 meters roughly, and then 1 kilometer is about 1.6 uh, meters. So notice earlier I said 5K is often a distance. That's 5 kilometers, right? That's often a distance for races. If we want to know how many miles that is, let's multiply it. I want to know in miles how many miles that is, and then I want to get rid of kilometers. Okay. So for every 1 mile, according to this thing, this chart here, we have 1.6 kilometers. Okay, and so the kilometers cancel. And then if we put that in a calculator, 5 divided by 1.67, well, we know it's going to be less than 5 because we're dividing by a number bigger than 1. And so if we plug it in, I get 5 divided by 1.6 is 3 and 1/8 miles, or 3.125 miles. Okay, so that would be the result that we get from this division. And so it's about a 3 and an eighth of a mile. So it's not exactly 3 miles. It's 3 and a little bit more. And this is very approximate. So this is a very rough. So we say 5K is about 3 miles, but it's a little bit more. Okay. Let's see, converting 125 miles to kilometers. So this is kind of similar to the example that we just did, except we're going the other direction. So if I want to know how many miles are in, or how many kilometers are in this 125 miles. So notice that it'd be the exact same thing, except for what we want. We want it to move upstairs. So we're given 125 miles, which is what you see here. Okay. I'm realizing my writing's getting worse, so I'll just leave it here. So 125 miles is what we see here. Okay, so we're gonna write that as 125 miles over 1 mile, over 1. And then we have 1 mile here, so then the miles cancel, and we're left with kilometers upstairs, which is what we want. 125 times 1.6 gives us about 200 kilometers. Okay. And then using dimensional analysis to change to and from the metric system. So if we have, let's say 200 or 26,800 millimeters, and we want to convert that to inches, the first thing to do is, since this is given to us in millimeters, we have a conversion for centimeters, not millimeters. So we first need to convert this then to this millimeters into centimeters. So that means multiplying this by a power of 10, which is what you see happening. I kind of did that off. I kind of did that off screen, if you will. So let's go ahead and do that real quick. So that's 26,800 millimeters, and I want centimeters, and I want to get rid of millimeters. Okay, so for every 1 centimeter, there are 10 millimeters. Okay, so the millimeters cancel, and I have 26,800 centimeters divided by 10. And so that's going to reduce this by 1. And so that's where the 2680 or 2,680 centimeters comes from. And then using this relationship, again, I want it in terms of inches. So the inches go on top, the centimeters go on the bottom. And so if I multiply 2,680 centimeters and multiply that by 1 inch, I get 2680 inches. And then I'm going to divide that so that the centers can cancel out by 2.54. So you get roughly that it's 10 or 1,055 inches. Okay. Now that may not mean a lot of sense to us. So we can take 1055 just to kind of give us another rep at this inches. And let's say we want to know what that is in feet, right? So I want feet. I have inches. So there, for every 1 foot, there are 12 inches. And so inches cancel. And if I take 1,055 and I put it in the calculator, divided by 12, I get that it's 87 point, I would say 87.99 feet. Yeah, 87.9 feet. All right, so that's a still pretty good distance, but I think that makes the number a little bit more reasonable for everyday experiences. 26,800 millimeters doesn't make a lot of sense to me. And even at 1,055 inches, I'm still having a hard time fathoming how far that is. So converting it to feet here helps me to kind of get a better handle on how far that is. Okay. All right, so that's the end of this lesson. So hopefully that was helpful, and I'll see you in the next video.